Welcome back to the last lecture of Module 1 for Introduction to C, Programming in C. I'm your professor, Professor Fiske, and let's jump right in to operators. I like using W3 schools because W3 schools is by far one of the easiest, most and comprehensive places that you can find what you need if you want to get all the bells and whistles that are a part of C. Then my suggestion is to go into open-std.org and get one of the older versions of the C language. Obviously, it's not the most up-to-date, but most of this stuff is still valid. Let's get into it. All right. So here we have our includes for string and bool. We don't need the bool. I don't like using includes if I'm not going to use them at all. I may use a string. Who knows? We'll leave it for now. Okay. Now, let's talk about operators. What are operators? Well, you might remember operators from elementary school, arithmetic, and whatnot. Please understand that operators are addition, subtraction, multiplication, division, and modulus. Those are the most important operators that you're going to run into when working in C. Normally, your arithmetic operators are the ones you see the most, and then we have other operators that we use as well. So as I said, we have addition, subtraction, multiplication, division, modulus, increment, didn't say that, and decrement. We won't go into increment and decrement in great detail here because we're going to use those when we go into looping. Here, we're just going to talk about main operators that we would use in everyday development and the corresponding shortcuts that we would use. So the first thing I would say is when we're looking at this equal sign means assignment, all right? Two equal signs in higher level languages like C, C++, and Java, C#. In those languages, two equal signs means equality, all right? Java is weird, where two equal signs doesn't always equal equality. If you're trying to look at like a number and a storage location, that's a different conversation for a different time. Just please understand that two equal signs means equality, one equal sign means assignment. So if I see one equal sign, that means I'm assigning the value on the right to the variable on the left, and that's it. If I see two equal signs, that means I'm trying to determine if the value on the right is the same as the value on the left. If you're developing in JavaScript or a scripting language like JavaScript, there is one more operator that you would use, and that's the triple equal sign. And the triple equal sign in that context, it's going to error here, but I want to talk about it in passing. It checks the right side to see if the right side has the same value or is equal to what is on the left, but it also checks to see if the data type on the right is equal to the data type on the left. Now, this isn't found in C, as you can see here. In C, we just have one equal sign or two. But let's say, for instance, I said I wanted to have bool x, all right? This is going to be weird, right? Does, and then I would say D. All right, what's wrong? Oh, I deleted bool because I said I wasn't going to use it, and I am. That was short-sighted. There we go. Bool is fine, but you might be saying, well, hold on. You never put true or false there. You just put, I put a number, and I said equals equals a number. And what the program think? The program said, okay, well, I'm going to evaluate, because I see two equal signs, I'm going to evaluate if this side of those two equal signs is the same or equals that side. So what do you think the answer is going to be? You can pause it here, write it yourself, see what happens. All right, well, if you figured it out, the answer is 1, because 56.3 does equal 56.35. I didn't say the whole thing. But what if I removed one of these? What would happen? Well, we should get false, because they don't equal each other now. 56.3, if there was a trailing 0 here, that would be a 0, does actually not equal these two. So what if I wanted to check to see if they don't equal each other? Well, what I would do is I would say exclamation point equals, and from now until the end of this class, that is not an exclamation point, that is called bang sign, all right? So bang sign equals means is not equal to. I will say that again. The bang sign means is not. You can use it for a lot of things. We'll be using it a lot in our flow control when we use if-else's and stuff like that, but really this means is not. It can be used all by itself. It's a reserved character. Equals is also a reserved character. Equals to. Is not equals to. This should return 1 or true. And would you look at that? It does. Nice. So these are the ways that we use operators here. And like I said, we're going to get more into these types of operators when we get into flow control. We're not there yet. But what I want to go over is math. So there's one thing about math that you must remember. It's the most important thing about math that we use in computer science. And it's please excuse my dear Aunt Sally, PEMDAS. If you don't remember PEMDAS, don't worry. The only part of PEMDAS you really need to care about is the P. The P stands for parentheses. Now, why do you think that's important? Well, everything in your stack trace executes in the parentheses first. So, notice in this line of code, we are referencing a method or a function. I'll say it's a function. We're referencing a function. But what happens is the program executes what's in the parentheses first. Then it executes whatever is outside of the parentheses afterwards. If you have nested parentheses, it will execute what's in the first or the innermost parentheses first, and onioning out of that per parentheses on the outside. All right? Now, the reason why I say parentheses is very important is because when you start doing these type of operations, you might want to determine specific true or falsy statements in succession, right? You want to see, is this true? Well, now is that true? Or is this true and is that true? We're going to go into or and in the flow control module. But here what I want to do is I want to talk about math. So we'll say double just to be safe, or even float. I like float actually. We'll change this to F, and we're going to say, well, does this work out just fine? The answer is yes, it does. Great. Well, what happens when I subtract these two things? What do I get? I should get 0.05. Negative 0.05. Quite nice. Great. But what happens when I multiply this? I get the correct multiplication. Let's do something here. Let's change this float, double, whatever, long double. Those are floating point integers, or floating point data types, remember? Let's change this floating type integer, or floating point type. Let's change it to an int. Remember what I said happens when you try to save a double, a float, or any other floating point type to an integer type? In this case, it threw a head gasket because I didn't change the format specifier, so it didn't know what to print. There it is. So if you look at this one, we have a very precise number, 3172.504883. Fantastic. Guess what we have down here? A not so precise number. As a matter of fact, I would argue this number is not correct, because if we round it up here, we'd be at 3173. I would round up. I'm just a positive person. But down here, notice it didn't try to round up at all. It said, well, I'm an integer, so all I'm going to do is remove the decimal numbers. Interesting. And that's what happened here. So whenever you try to save a decimal type or a floating point type to a non-floating point type, like an integer, what happens is that everything after the decimal is removed, truncated, and all you get is the absolute value of that number. And that's it. This is kind of where I wanted to go with this, but there's one more thing I want to show off, all right? We talked about addition, subtraction. Let's talk about division, just so that we can cross that bridge, all right? It's not going to print because I didn't change the format specifier. So let's change the format specifier so it prints correctly. That's not correct. Float x equals 1 divided by 2. 1 divided by 2 should be 0.5. 1 divided by 2 should be 0.5. Why is it not printing that? Interesting. That should be 0.5. Why is it not 0.5? Interessante. I didn't mean to go back to ASCII 2. Double x equals 1 divided by 2. Right? Interesting. And I can't debug this, can I? I would like to, but I don't think I have upgraded my... let me turn you off. No. Thank you. I have not upgraded my replet for that. But it will keep printing that, unfortunately. What about 3? Huh. Is that because... Oh, bollocks. No. It doesn't like it. That's interesting. That is interesting. I'll look into that. But what I want to go over is modulus. Ha. So what is modulus, right? Let's do this instead. Let's do 2. What is modulus? All right? What is modulus? Modulus means remainder of. That's what modulus means. So if I said 3 modulus 2, what would I get? Well, I should get a remainder of 1. And the reason why I should get remainder of 1 is because when you divide 3 divided by 2 and you're in the 3rd grade, what happens? You carry the, you say 1, then you, 2 divided by 3, I should say. You say carry the 1, 3 minus 2 is 1. That's the remainder. We don't go any further than that. Now, you might be asking, well, why in the hell would I ever use modulus? You use modulus for very interesting mathematical counting, like when we're counting the Gregorian calendar. If we want to know what month we're in, or what day of the week, or time, we would use modulus. When you're doing the Fibonacci sequence, you can use modulus. When you are determining whether a number is even or odd, you can use modulus. So in this case, 3 modulus 2 means, well, 3 is not an even number. But I guarantee you this is 0. Because 4 is an even number. Now 4 is an even number dependent on this, because this really means 2 divided by 4, 2, if I can draw, at least if I can draw, 2, 2 divided by 4, right? And what you'll have is you'll do 2, which is 4, and there is nothing to return. But if I did 2 divided by 3, and pardon my ability to write here with my mouse, well, I would say 1, because 1 times 2 is 2, which is this the highest number I can get to 3. This minus 1 is 1, so the remainder is 1. This is an odd number. Nay good. Or good, depending on what you're looking for. You might not be looking for an even number. Everyone, I always look at even as being good, but it's neither here nor there. That is your crash course in operators. There are many other operators we're going to talk about, and we are going to talk about them going forward. I don't want to overload you in this specific module. Otherwise, it was great having this lecture with you. If you have more questions, just reach out and let me know. Otherwise, I want you to know that I'm here if you need me. Always keep on trying to stay plugged in. This is a lot of information fast, but I'm sure you'll get it in no time flat. Otherwise, good luck. Have fun. Ciao.